Example 1 asks us to find the area of the parallelogram. Now, when I'm always finding the area, I'm always going to start with one thing, a formula. So that formula that was given to us above in the key concept, area equals base times height, is the way I'm going to start off every single problem. Then, in this case, in order to figure out my base and my height, I'm going to have to count the units on my grid there. So I'm not counting how many squares are filled, but I'm counting the length of the base and the length of the height. So when I'm counting my base, I'm counting here 1, 2, 3, 4, 5, 6 units is the base. And then when I'm counting the height, again, I'm counting the length, not the squares that are filled, just the length of the lines. 1, 2, 3, 4, 5, 6, 7, 8. So the base is 6 units and the height is 8 units. So that would be, my next line would read A equals 6 times 8. And then I can multiply those to get that the area is 48. And I want to make sure I label it. Because I'm multiplying 6 units times 8 units, my units will now be units squared. So always with area, since you're going to be multiplying two measurements, the measurement is then going to become squared. So here you can write that as square units, or you can write it as units squared like this, or sometimes people will write it out and abbreviate square and write square units this way. Okay. You can see a bunch of examples over here on the left-hand side. So if it's inches, it'll be inches squared, or if it's square feet, I can write it as feet with the little exponent too. Same thing. So it depends on whatever the unit is. What you can't do that is not the same, and you want to just be careful. So you cannot, for this one, I can't write 48 square units like this. Okay, because what this is saying, it's saying that you're squaring your 48, which would mean 48 times 48, and that's a really big number. That is not the correct answer here. So you want to make sure that this exponent is with your units, not with your number.